All right, are y'all ready? We're going to do the second half of slabs. I know this lesson is kind of tough. Remember, I'll be teaching it live. Y'all can always kind of watch me watch it live. Okay, so this time, find the volume of a solid whose base is enclosed by a circle. We haven't done a circle yet. They're not hard. You just got to think about some stuff. So let's get, we've got a circle. And I'm going to be nice, and all of our circles will be centered around the origin. So if this is x squared plus y squared equals 7, then we know r is the square root of 7, and that doesn't really matter. We just, there's the center, and we go out the square root of 7. Okay, so we know that this is the square root of 7, 0 is that. This is 0, the square root of 7. This will help us just a little bit thinking about it this way. Okay, and like I said, all of your circles are going to be centered around the center, so we won't be mean and make you move them off to the side. Okay, the cross sections are perpendicular to the x-axis and they are semicircles. So that means we have a semicircle sticking up out of our paper. What did I do with my... Okay, so that means I have, let me cut this out. Again, y'all can cut some shapes out of paper at home, and that may help you see. So if you look, oh, that's way too big. So if you imagine, right, I've got these semicircles sticking up all the way. So this is going to look like a ball that's been cut in half. So it's a half a dome, right? Or a dome on the ground. So we've got semicircles and they're perpendicular here. So here's what we need to think about. They didn't give us two curves, but if you'll think about it, I have the top half of a circle here, and I have the bottom half of a circle here. So because it's perpendicular to x, it's the top minus the bottom. You'll also notice with circles that doesn't matter, right? Whether you're going dy or dx, you get the same problem. This, of course, is a dx because we're perpendicular. So what I need you guys to figure out is what is the equation for the top. Well, we've got this equation here, and it's dx, so we need y by itself, right? Because we're going to say y equals something to get it in terms of x. So y squared equals 7 minus x squared, right? Y equals, so we're going to square root both sides, plus or minus the square root of 7 minus x squared. Okay, the nice thing is all of your circles are going to turn out this way. So once you do one, you get used to them and it's the same thing. So let's look at what happens though, because if you look at it real quick, you're going to say, well, the square root of 7 minus x squared minus the square root of 7 minus x squared is going to give me 0, but it's not, because what we have is the square root of 7 minus x squared, that's the top, minus the bottom, right? And what is the bottom here? Negative 7 minus x squared. So this becomes what? So the actual diameter, anytime we talk about circles and we're doing top minus bottom or right minus left, it won't matter because it's a circle. Your diameter, right, equals 2. Think about that for a minute, because that's always going to be true for you. So if that's the diameter, and sometimes you may need the diameter, if it was the side of a square, that would be the length of a side of a square. But in this case, it says the cross sections are semicircles. And we know that the area of a semicircle is 1/2 pi r squared. So we need r. So if the diameter is 2, then the radius is just that. So think about that, because like I said, that's going to be true on all of your circles. You know what the radius is. You just get a letter by itself and you know what the diameter is, okay? So let's go back to the problem. The cross sections are semicircles, so we need the side, or we need that area. So it's the side is going to be what? The side is 2 square roots of 7 minus x squared. Therefore, the radius equals the square root of 7 minus x squared. Okay, so the area then of that circle, semicircle, is 1/2 pi r squared. Well, tell me what happens when you square the square root. The square root of 7 minus x squared is just going to be 7 minus x squared, right? So that's 7 minus x squared. If you need to, pause this and think about that for a second. We squared r, and when you square a square root, it takes the square off, right? So there's 1/2 pi r squared. So now we're going to integrate, and of course, it's easy to know where you're going because we put these points on. That makes it easy. We're going to go from negative square root of 7 to the square root of 7, and it's going to be pi, 1/2 pi is pi over 2, r squared, right? And r squared is 7 minus x squared dx. So take a second, type that in, and you get 38.789. Hopefully these are starting to feel a little better. I know they're strange. I highly recommend you come to a lesson live so you can ask your questions as they happen. 2 more problems to do. So see, we're almost done, just 2. And these are weird shapes. Since they're weird shapes, y equals e to the x, which I know scares you right away, and y equals x plus 2, we went ahead and gave you the picture, and we gave you the intersection points so you don't have to do that. So of course, y equals e to the x is this right here. Again, it's good to frame them in so you could see who's where. The volume of this solid, find it if the cross sections are equilateral triangles perpendicular to the x-axis. Okay, perpendicular to the x-axis tells us it's dx. So what do we have here? We have little triangles sticking out, and all 3 sides are the same. Now we have a whole bunch of those, right? So let me get my handy dandy scissors. So we're going to have these triangles, right, sticking out, and they're stacked up one after the other, just all these triangles, okay, sticking up out. So you know what it would look like? It's going to look like a Toblerone bar stuck in there. You know those chocolate triangle bars? You should eat one while you're doing this. There's our plan. There we go. Okay, so we're going to do top minus bottom. So that's top. Notice it's easy. I see green is on the top. I just go over to the green one. For me, my eye always takes the equation I see first, and I tend to make careless mistakes. So again, top minus bottom. And the bottom is pink, so I just look at what I highlighted in pink. There we go. Okay, now what is the area of an equilateral triangle? Area of a equilateral triangle is square root of 3 over 4 times s squared. Well, we already know s. This is s right here, so it's just the square root of 3 over 4, right, times, if you can hear little toenails, that's my dog running around. He's mad because I'm not walking in time. We're walking a little bit. Okay, so now we'll set this up. and you can find your points. It's very important that you know it's dx. Therefore, we are going to choose, excuse me, the x values. If this was a dy problem, then we would pick the y values, okay? So we are going to go from negative 1.847 to 1.146. And I'm going to pull out the square root of 3 over 4. I find it easier to type these into my calculator if my constant is out front. X plus 2 minus e to the x squared dx. Okay, take a minute, hit the pause button, and you type that in. All right, you're back, and that is 0.669 units cubed. Okay, all right, can you bear with me? One more to do. You got it, one more. Then I promise I'll let you go for the day. Okay, so it's the same shape, right? So I'm going to be consistent, and I'm going to do this one green so I can see it. And I'm going to do that one pink. Again, you don't have to color code, but I think it pulls your eye to the right one. Okay, find the volume of a solid. If cross sections are rectangles perpendicular to the x-axis such that the height of the rectangle is 3 times the length of the base, is it dx or dy? Well, it is perpendicular to x, so that makes it a dx. That means when we read it, we're going to use the x values. Okay, so I have a rectangle. Oops, I got to make it smaller. Again, it wouldn't hurt you to cut out little pieces of paper. So this is a rectangle, right? And it's standing up on there, sticking up out of the paper. So can you see that? It's sticking up out of my paper. And you would have a whole bunch. They would get smaller here because the one down here would be very tiny this way, and it's 3 times as tall as it is long. So we got these rectangles sticking up out of the paper. Right, so let's draw this rectangle. It's this right here sticking up out of the top, kind of. Right, in a 3-dimensional shape. So it says that the height of the rectangle is 3 times the length of its base. So the length of the base is going to be top minus bottom, so that's going to be S. Or you could put B for base. It doesn't matter what letter you use. And the height is 3 times as tall. So what is the area? Well, you know the area of a rectangle is the length times the width. So area equals 3S squared. Correct? So it's going to be 3 times S squared. So now you just need to figure out what S is, and S is going to be top minus bottom. So that's x plus 2 minus e to the x. Not so bad, right? There we go. And we'll integrate it. Again, I'm going to pull out my constant. It's easier to me to type when that's not there, because then I don't need 2 sets of parentheses. And of course, we already gave you the numbers, so we're going from negative 1.847 to 1.146. Okay, so hit the pause button. Okay, you're back. Did you type it in? It is 4.634 units. And that concludes our day on slabs. I hope it wasn't too stressful. Remember what slabs are. They're shapes sticking out of a flat surface. The shape you draw on your paper gives you the flat surface, kind of like the driveway, if you will, and then you have to figure out what is sticking up out of the top. It's not a bad idea to draw a little shape so you can see. So I hope you have an absolutely phenomenal, marvelous day. Adios, amigos.